So my name's Mark. I'm here at DesignCon 2026 with Matt.
Mark, thanks for having us. Matt Burns from Technical Marketing Director at Samtech, and we're excited to be here at DesignCon with Mark from Synopsys. And we're going to talk, in our video today, we're going to talk about the joint demo that we have here at DesignCon 2026, featuring the 224 technology, both from Synopsys and from Samtech. Can you talk about the Synopsys part of the demo, Mark?
Sure. We have a test chip for our 224 gig serializer PHY, and we're generating a 224 gig PRBS31 pattern, which is going into your cable. And can you tell me about your cable?
Mark, that's my favorite part of this video. I'd love to. So you'll notice that the signal, after it leaves the Synopsys test chip, it goes through Samtech's Bullseye RF high performance test system. That's an RF breakout technology that takes signals from the IC outward to the system. The signal passes through the high precision RF interconnect over to an evaluation platform for a brand new 224 gigabit per second interconnect system from Samtech that we call Sci-Fly HD backplane. The entire channel, pad to pad, from the test chip to the evaluation platform to the passive backplane cable and back to the system, has an insertion loss of 43 dB at 224 gigabit or 56 gigahertz. The reason that we have so much loss is not only the fact that we have low loss on the cable, but there's about 14 dB of loss in system due to the evaluation platforms. Combination loss between the Synopsys PCB and the Samtech test PCBs. If we take the loss of that system out, we could extend the reach of the passive backplane from a ½ meter at 224 all the way out to about 1.5 meters in a real system. So when looking at this cable, that's a great interconnect solution used for scale up, scale out for GPU scaling, and the like.
And I'll bet that in this system, where we have all of the different connectors from the Bullseyes to the 1.85 millimeter, we're probably also getting some other reflections and things that are impacting, which you wouldn't have in a real system, where you just went from the IP straight out through the cable and back again.
Of course, Mark, that's a great point. A lot of the discontinuities that you have because of the interconnect transitions, those wouldn't be present in a real world system. But despite all those discontinuities and all those interconnect transitions, what's driving the good results that we see here on the screen here?
So once the signal comes back, it's been degraded quite a bit by the cable or all of the distance, everything. And we go through an A to D converter. This is a histogram of the data coming out of the A to D converter, and as you can see, it looks just like random noise. It then goes through a long feed-forward filter, digital filter, and after going through the filter, you end up with this distribution where there are 4 discrete groups for the 4 different levels of the PAM4 signal. Taking that, we can extract the original data and look at the bit error rate that we're getting. And we're getting a bit error rate which, over the past day, our average has remained very constant at about 2 orders of magnitude better than what the spec is calling for. So,
and just to make sure we capture, what's the value of the BER that we're seeing here roughly?
Around 5 times 10 to the minus 9.
That's really good for this channel and at that Nyquist frequency.
It's an impressive system.
We're equally excited about the opportunity to present this technology to our listeners and our attendees here on the video. For more information on Samtech's Sci-Fi HD backplane interconnect technology, visit our website, samtech.com.
And for more information on the Synopsys IP, you can visit our website at synopsys.com.
Hi there, my name is Abhinav. I'm a Principal Product Manager for Scale Up and Scale Out IPs at Synopsys. We also have with us here today Mark from Synopsys.
My name is Mark Sauerwald here at DesignCon 2026, and I'm an applications engineer specializing in high-speed SerDes technology.
Our team at Synopsys provides a complete integrated solution for Ethernet, Ultra Ethernet, and UA-Link, which includes the controller, PHY, PCS, and verification IPs. These IPs enable the ecosystem adopt technologies to enable high-speed connectivity for next-generation AI and HPC workloads. We're here at DesignCon 2026 today, where we're demoing the performance of our 224 gig PHY IP. So Mark, what do we have for our demo here today?
So this is the evaluation board that we use for our 224 gig IP test chip. And we're using that to generate a 224 gig PRBS signal
which is going through a channel. This is the Hirose connectors with an FPC channel, which is typical of what would be used on a chip-to-chip connection in high-speed computing. The signal comes back to our chip where we do some analysis on the signal coming in to recover the original signal. We go through first an analog front end with some equalization and gain control, and then we go to an A to D converter. The signal at this point looks like a lot of noise. We go through a digital processing section, and we end up with a distribution which shows 4 discrete levels from the PAM4 signal, and we're able to recover the data and measure a bit error rate. The bit error rate that we've been seeing on this for the past 20 hours is 1.5 times 10 to the minus 12 bits. So very good bit error rate.
Thank you, Mark, for that comprehensive walkthrough of our 224G PHY demo. Synopsys leads the industry in providing 224G PHY technology. Our PHY is able to demonstrate an industry-leading VER that is 100,000 times better than what the standard defines. We're able to achieve this performance at a reach of over 2 meters of passive DAC cables. This IP has been silicon proven in multiple process nodes, and we've been showing interoperability with a variety of electrical channels, connectors, optical modules all across the ecosystem. Our joint work with Hirose here strengthens our interoperability ecosystem and accelerates deployment for next generation data centers.
If you want to know more, you can go to synopsys.com and see our website and get more information on this and get set up to look at your own parts.